Nick Shaw here, and thanks everyone for joining today's webinar. Today we're talking through double stud construction, and we're mainly looking at wall assemblies. The roof assemblies could look like a wide variety of things. Double stud isn't necessarily referring to a roof assembly, but it is to a wall assembly. So as we're kind of going in, I just wanted to make sure we're all on the same page of what a double stud wall means. Double stud is meaning two stud walls. There's typically, they're oftentimes spaced apart, or the studs are staggered, and the idea is that we're helping eliminate any thermal bridge by insulating between the framing or staggering the framing so we can insulate between where that frame would meet the exterior and the interior. So here we have our kind of standard typical double stud wall assembly from our Smart Enclosure ebooks. A lot of what I'm talking through today will be referencing different drawings from our double stud ebooks. So if you haven't already, please check out our Smart Enclosure ebooks. They're free to download on our website. They cover a wide variety of different types of construction. Then we have one just about double stud construction. Those are DWG files or PDF files. With the DWG files, you can drag and drop and adjust them as you see fit. But double stud is really great because we can prioritize a thick layer of fluffy fibrous insulation, typically insulation that we shouldn't get wet. Cellulose, fiberglass, things like that. Materials that also tend to be significantly lower cost. And they're oftentimes considered risky assemblies because there's no exterior insulation. And a lot of what we'll be talking through in this presentation is that an interior air barrier is key for double stud assemblies. But to even further reduce the risk, we want that air barrier to be vapor variable, i.e. the INTELLO Plus or the INTELLO X membrane. So we, in general, want to be prioritizing an interior air barrier, and that interior air barrier can double as your vapor control layer. And nowadays, we're using materials that are vapor variable, that respond to the relative humidity around it. That's what the INTELLO membrane does. But the general idea that we're trying to prevent is your soda can or your beer can outside on a summer day. Condensation occurs when warm air meets a cold surface. And so with double stud construction, we don't have exterior insulation outboard of our sheathing. And so we have this concern of our warm air moving through the insulation during the winter from the inside and condensing on that cold surface, the backside of our sheathing. We're looking at the backside of our sheathing as our high risk point. That is that principle of that cold soda can or beer can out on your summer porch. That is warm air meeting that cold surface and condensing and causing that sweating effect. And we want to prevent that in our walls. And one way is to have exterior insulation that's vapor open, vapor permeable, whether that's Gutex wood fiberboard or rock wool exterior wood mineral stone wool insulation. But another approach is where you don't have exterior insulation is to have an interior air barrier. That's where this red dotted line is. And that is keeping the conditioned air in the conditioned space. So that way your warm air won't move through that insulation and condense on the backside of that sheathing that's cold. And in double stud construction, the backside of that sheathing will be cold because we have no exterior insulation. So that interior air barrier becomes really key. And that interior air barrier does mean that we're applying drywall oftentimes directly to it, or best case, including what we call a service cavity. This is strapping, oftentimes horizontal strapping. That's a chase to run our electrical components. And I'll get into later on in the presentation that there are opportunities to use that interior stud framing as our service cavity. So that way we don't need this additional horizontal strapping as we're showing here in more typical 2x construction. You can do without this, but devil's in the details. Then you'll need to be air sealing around all your outlets. So that interior air barrier is the INTELLO Plus or the INTELLO X membrane. These are interior air barriers that are incredibly airtight and that are vapor variable. They are changing their vapor permeability based on the relative humidity around it. Both INTELLO Plus and INTELLO X have the same vapor qualities, the same vapor curve. The INTELLO X is just a more robust version, i.e. more puncture resistant. So we're typically using that on multifamily or metal frame construction, while wood frame, single family residential, we're more comfortable with the INTELLO Plus membrane. So this INTELLO membrane would be this red line that we're showing on these roof assemblies. And during the winter, cold air is dry. So we have a low relative humidity. And this membrane is responding to that relative humidity and becoming a class 2 vapor retarder. This is also during the time of year when our vapor drive is heading towards the exterior. So by having this interior air barrier that is changing to a vapor retarder, we're not moisture loading that assembly with our interior humidity. And then during the summer, we have that warmer air that can hold more moisture. We have a higher relative humidity. This membrane responds to that high RH and becomes a vapor open at 13 perms. So it's corresponding to the relative humidity, which also corresponds to our vapor drive. And mold tends to grow or accumulate at about 80% RH. It depends on the substrate of the material, but that's oftentimes our risk point for mold growth or moisture concerns. And you can see in this vapor curve that the INTELLO is opening up at about that 70 RH threshold. So we have vapor permeability on the vertical, and we have relative humidity on the horizontal. And we found this is really the sweet spot for this vapor curve. A lot of other vapor variable membranes open up too soon. They become too vapor permeable and lower RHs. Or some of them start to open up at the right time, but they don't open up enough. They're maxing out still as a class 3 vapor retarder. So this is the INTELLO membrane, and it's really been optimized and has this really nice vapor curve. And this is a really strong way to reduce risk, especially when we don't have exterior insulation, especially when we're doing double stud construction. So this interior air barrier that is vapor variable becomes really key for double stud construction. Here's our kind of typical double stud wall assembly. On the exterior, we're having whatever type of siding with a rain screen. A rain screen is a vertical strap or a 3D mesh material that's creating a drainage plane and vented cavity outboard of the house wrap, inboard of that siding. We're then using the Solitex Mento 1000 membrane. This is a vapor open, water resistant barrier. It is airtight, watertight, and incredibly vapor open at about 38 perms. Then we have a 1/2 inch of plywood sheathing, and we're looking at 10 inches of cellulose. This was R3.5 per inch cellulose. And then we have the INTELLO membrane on the interior side with drywall. So what we're about to be looking at is a bunch of different hygrothermal analysis. This is a modeling program within WUFI that is looking at how moisture and temperature interact within an assembly. And what I did is I modeled this exact assembly that we're looking at right now, this 10 inches of cellulose with the 1/2 inch of plywood, and I modeled it for a variety of different cities in the Northeast. And we looked at whether or not including the INTELLO or not including the INTELLO.
You know, it's a little bit white.
So when we're looking at models, the key thing to be noting is there's a lot of assumptions being made in model programs. All models are wrong, but some are helpful, some are useful. So again, this is looking at how moisture and temperature interact within this assembly. And we're actually going to be modeling it in these cities that you're seeing over here. So this is all in climate zone 4 through 6 in more humid climates, i.e. A. And again, that assembly is the siding with the rain screen, the Solatex Mento 1000, a ½ inch of plywood, then 10 inches of cellulose, then the INTELLO membrane, or we'll also show it without the INTELLO membrane, and then the drywall. We're looking at the back side of the sheathing, the interior side of the sheathing of our high risk point. And we tend to want to stay below about 18% moisture content for that plywood. Some folks will say more like 20, but we're being a little bit conservative to say we want to stay below about 18% moisture content. So we're about to look at a bunch of graphs where we will have time on the horizontal and then moisture content of that plywood on the vertical. And you'll see lines where it's showing with INTELLO or without INTELLO. The big thing about this modeling program is that drywall as a material is airtight. So all of these assemblies I'm about to be showing have an interior air barrier. And the key difference is whether or not it's including the INTELLO's vapor variability. So just by having an interior air barrier, we're keeping our warm air in that conditioned space and not letting it move through that insulation where it would condense on the backside of that cold sheathing during the winter. So that's a really great way to be reducing risk. But we can further reduce risk by making that interior air barrier vapor variable. Sorry that I didn't mention it previously, but throughout this whole presentation, please feel free to put any questions that you have in the chat, and we'll go through and discuss those questions at the end of the presentation. So first, we're looking at Quebec City, which is in climate zone 6A. So we have time on the horizontal, and we have moisture content, water content of the interior slice of that plywood on the vertical. The blue line is an assembly without the INTELLO, and the green line is the assembly that includes INTELLO. They're both starting with the same moisture content. I actually doubled the initial moisture content of all of these materials so we can see how quickly they start to dry and find this equilibrium. We have a red dotted line at 18% moisture content, i.e. our risk threshold. So we want to make sure that we're doing our best to stay below that 18% moisture content. And so we can see by having an interior air barrier that's not vapor variable, we're having these big spikes. We're actually peaking at 27% moisture content in that equilibrium. And by including that INTELLO, we're peaking more at 16.2% moisture content. So significant reduction in risk. And by including this INTELLO membrane, we actually make this a very low risk assembly. It will still take that first, half a year or so for that assembly to dry because we're starting with everything so wet. But once it does dry, it finds a very low risk equilibrium. The blue line is just drywall with no vapor control, just an airtight material that is truly vapor open. We are not talking about a poly membrane. A poly membrane would trap all that moisture, and we would see that initial moisture content kind of stay the same pretty much. While the green line, again, is the vapor variable membrane, the INTELLO Plus membrane. Now we move a little bit south into Burlington, Vermont. We're still in climate zone 6A. We're still starting off with doubling that moisture content. And now we can see that the blue line, i.e. the assembly that's only using drywall as their interior air barrier, we're getting consistent peaks above 20% moisture content. Still a fairly risky assembly, but by including this INTELLO membrane, this vapor variable membrane, we're peaking at about 16.2% moisture content. a fairly low risk approach for this. Now we're shifting to look at Toronto. We're now in climate zone 5, 5A, still a humid climate. Again, the blue line does not include INTELLO, it's just airtight drywall. And we're getting, an even higher peak of that equilibrium, where each season it's reaching up to 24.6% moisture content. But then when we include the INTELLO, we greatly reduce that risk. We greatly reduce that moisture content of the plywood, and we're at 15.7% moisture content. This is the interior side of the plywood. So again, I'm just going to pull up the basic wall assembly, so make sure we're all on the same page. The moisture content that we're looking at is the interior piece of this 1/2-inch plywood sheathing. And all of this is 10 inches of dense packed cellulose. And the model is assuming that celluloses are 3.5 per inch. And we're including the INTELLO or not including the INTELLO. When the INTELLO is not included, it is only the drywall that's the interior air barrier that has zero vapor control, just truly vapor open. So Toronto, again, we're greatly reducing risk by including this vapor variable membrane, the INTELLO, on the interior side. In Chicago, without the INTELLO membrane, we're peaking at 19.8% moisture content. I would say that's still fairly risky. It's still above that 18%. It's a little bit below the 20%, but it's too close for my, what I would consider low risk. But by including that INTELLO, we're greatly reducing the risk by bringing it down to peaking at 15% moisture content. So again, just by including this vapor variable membrane, the INTELLO membrane on the interior side, we're really greatly reducing the risk of these double stud assemblies. In Boston, Massachusetts, we're still in climate zone 5, 5A, still a humid climate. Again, without the INTELLO, we're peaking at 19.6% moisture content, a little bit too risky. And then with the INTELLO, we're peaking at 15.8% moisture content. All of these are still having that same initial wetting of doubling the moisture content of all the materials within the model. So still greatly reducing risk by including the INTELLO membrane. Philadelphia, now we're moving into climate zone 4. So a more temperate climate, and we're still having that initial moisture loading by doubling the moisture content of everything. But even with airtight drywall in climate zone 4A in Philadelphia, we're getting at 20.8% moisture content consistently. But again, by including the INTELLO, we greatly reduce that risk and bring it so it's peaking at 16% moisture content. We move to Baltimore, still in climate zone 4, but considerably more southern. And now we start to see how just having an interior air barrier is what's really key in these more warmer, more humid climates. So without the INTELLO, we're showing that in the blue line, we are staying below the 18% moisture content. We're now at 17.5% moisture content. So I would say a lot of people would be saying that's a low risk assembly. We're not reaching 20, we're staying below 18%, but we're even further reducing that risk by including the INTELLO even in climate zone 4A, and now we're peaking at 14.2% moisture content. So considerably lower risk than just relying on your airtight drywall. So this is all to say that when you have double stud construction, or really any assembly without exterior insulation, you need some interior air barrier. And in your more northern climates, or when you're super insulating, or if we really just want to be considerably lower risk, that interior air barrier should be vapor variable, the INTELLO Plus membrane or the INTELLO X membrane. It's a really key way to reduce the risk in this high performance construction. We have different types of insulation. For double stud construction, we tend to like blown in insulation. There are approaches where we can be using bats or vapor open boards, but a lot of folks like to prioritize a dense pack insulation that they can fill all of those cavities completely. We don't want any voids within that insulation. Cellulose is a really great option. Recycled newspaper. Wood fiber is also a really great approach, and even fiberglass can be a really low risk approach. There's also stone wool or mineral wool, whether that's from rock wool or thermofiber, or sheep's wool is available in the US. I know Havelock is supplying that, and really excited to see more and more projects using chopped straw. I'm mainly seeing that in more of the prefab world where projects are having chopped straw wall panels that they pack those panels in their manufacturing site and then ship those to the job site. But excited about more opportunities for chopped straw in residential construction and commercial. So we're going to now be looking at a variety of different types of double stud. The kind of main differences is the exterior wall. This stud wall over here, is that the wall that's structural, or is the interior wall structural? Which one is structural will be kind of determining oftentimes your floor transition detail. A lot of these projects don't have sheathing. They're oftentimes using diagonal strapping, but we can be using sheathing on these. But first we're looking at where the exterior wall is the structural wall within double stud. And so with this, we are oftentimes seeing that interior strapping, that service cavity inboard of the INTELLO. And here we're showing that floor transition where we have this interior air barrier, the INTELLO wrapping around this floor system to be complete and continuous. This approach is significantly lower cost to implement for wrapping this rim joist, but it does mean that we're losing that interior air barrier at this floor system. So you can continue this INTELLO directly up and tape to the underside of that subfloor sheathing, but then you need to tape around all of your floor joists that are interrupting that connection. Another option is we can be placing airtight blocking between those floor joists and then tape those joints or use the Viscon, the spray-on air barrier for those transitions. Another option is to have the interior wall be the structural wall. Now your floor system and everything is resting on this interior wall, and this exterior framing is non-structural. This is getting closer to what we oftentimes call an I-joist assembly or a Larson truss when it's a retrofit. That approach doesn't have bottom plates typically. The main difference is that an I-joist is oftentimes hanging that wood outrigger to this interior structure, while with the double stud, this exterior structural wall is still standing or sitting on some bottom plate. It just isn't necessarily structural, but it is a fully framed wall. And so with having an interior structural wall, we get more of an opportunity to use that interior wall as our service cavity. So you can see in this image that here's our interior framing, and the INTELLO membrane is actually outboard of that. So now they could dense pack with cellulose, or they could place a fibrous bat insulation between the stud framing, and that is also where they'll be running their electrical components. So this uses less framing because now you don't need an additional service cavity. Here we're showing that just being raised up. This INTELLO is applied to the wall. It could be applied before they raise the wall or afterwards. If this is sheathingless, then oftentimes there's diagonal strapping being applied upward of that INTELLO to kind of pin everything in. Or if this was using sheathing here, the INTELLO could be on either side of that sheathing. Here again, we're just showing using that interior wall framing as what we call that service cavity, that chase for the electrical components. Here you can see that this INTELLO is coming up and is actually being taped to this window buck. The windows are oftentimes located in the middle of your insulation layer. That's how we get the best thermal value out of our high performance windows. So we tend to have deeper exterior sills with our double stack construction. And when we have that interior structural wall, that floor transition becomes quite simple. We can just run that membrane continuous. Now our floor system is not interrupting that transition point. So again, this is pulled right from our Smart Enclosure ebooks that are free to download through our website. Another option is utilizing the Smartrock boards. Smartrock is a new product. It's a partnership with 475 and Rockwool. So these are interior rigid boards that have the INTELLO pre-applied to it. So these are stonewool insulation boards with the INTELLO already installed. And what works really well for double stack construction is we can insulate that exterior stud wall between those framings with a bat, and then place this board to run continuous between the framing. 475 does stock the 2.5-inch version of the Smartrock board, which could be a good option for this approach. Might depend on your climate zone, but then you can tape all of those seams and then of that Smartrock board, and then run another interior non-structural wall that is your service cavity as well. So this is using the Smartrock board for a double stud application. The Smartrock board was developed to run continuous inboard of masonry, CMU block wall typically, but this is a really great opportunity to run a continuous in wood framing. And luckily, the fastening schedule is still very simple. So on the left side, we're showing the fasteners required for 16-inch on center framing, which would be 4 fasteners. Well, it's really like 3 because there's 2 in the middle and then 1 on either end. That's kind of splitting right at that seam. So here you can see the seam of the boards and that fastener's landing right there. While 24-inch on center framing, you have 1 just right in the center, and then 1 on either side at those seams, much more similar to the typical masonry fastener approach. But really excited about the Smartrock board being available, and excited to be using it on double stack construction. So please reach out to us at 475. I'm happy to discuss application and set you up with pricing for Smartrock applications. That floor system will be interrupting this Smartrock board, and with this is pulled right from the install guide. You would just tape around where that beam is interrupting that INTELLO. So you can notch that board. The Rockwool Smartrock board actually cuts quite nicely using this serrated blade, and then you would tape around where that beam is interrupting the INTELLO membrane. Here we're showing that using the Contiga Solido IQ tape. But you tape the seams of the Smartrock board and over the fasteners, and then around these floor joist interruptions. So we kind of gave a little bit of an overview of double stack construction. We looked at some WUFI hygrothermal analysis. Happy to discuss that further in the questions at the end of this presentation. We were looking at whether using the exterior wall as structural versus the interior wall, and then also using the Smartrock component as the continuous insulation between the framing. We're now going to look at a quick little case study. This is a Passive House certified project that was also LEED Platinum, and it's in Quebec in Canada. Beautiful single family home here. And first looking at the foundation, the wall transition. So they used their subslab poly membrane, and they brought that up above grade. So that came from under the slab, and they turned it up their little walls, and you can see the Contiga HF That's this green adhesive that's used here to help hold that membrane in place, also air sealing to that poured concrete. Any seams were taped with either the Tescon Vanna tape or the Campego tape, but that will be taping directly to the wall's air barrier. Here you can see that they actually wrap that floor rim joist using the Mento membrane. You can see that Stego, that subslab poly sticking up, that membrane wrapping around that floor system. It's really great to use a membrane for these floor transitions. Devil is in the details, and it can get complicated at the building corners. So I'm seeing a lot of projects switching to a wide tape for wrapping around that floor joist just to help ease the transition at the corners. That folding and origami can get a little complicated to tape at the building corners if you're using a membrane to wrap the rim joist. Here we're showing that rain screen application outboard of the house wrap. So you can see they use the Solitex Mento 1000 membrane. It was mechanically fastened, stapled, installed, and then taped the seams. And then they have a rain screen outboard of that. That's this vertical strapping to create this drainage plane and vented cavity. Here you can see that interior air barrier that is vapor variable, the INTELLO membrane turning into that rough opening, and it's actually getting taped directly to the windows. You can see that there is a little bit of origami and taping done at those corners to make sure we're not having an air leak as that membrane's folding in the corners. And then there's a continuous air seal on all four interior sides of the windows. So we're waterproofing on the exterior side, and we're air sealing on the interior side of the windows. And that air seal does mean we need to tape all four interior sides to make that complete and continuous air seal. This project actually first installed an insul web, a netting material, and then blew behind that, and then covered that with the INTELLO membrane. The INTELLO Plus and the INTELLO X are both robust enough so you can dense pack directly behind it, but you are then blowing behind an airtight material. So you need to puncture air relief holes, because as you're blowing in that insulation, you need the air to be able to escape. That's just a very slightly different approach than using the insul web type of cellulose netting that the installers commonly use. And so if you don't want your installer to blow behind the INTELLO, that's fine. You can install the INTELLO afterwards. But there is some, nice simplicity of only installing one membrane, saving on those labor costs, and just dense packing behind the INTELLO Plus or the INTELLO X membrane. The INTELLO Plus has that netting built in so it can support that dense pack, and the INTELLO X is just a more robust membrane and can handle supporting that dense pack even without that netting. They stuffed and filled in around that window opening on the interior with some more fibrous insulation, some vapor open insulation. We're not using can foam to can foam in our windows. That foam is not a good air seal because we're applying it to wood that expands and contracts, but also the foam tends to be a vapor retarder, and we don't want to trap the moisture at that high temperature differential. And we have a beautiful home at the end that is ready for occupancy. So this was a Passive House certified project, also LEED Platinum in Quebec. And a fairly simple structure. A lot of these high performance homes are trying to reduce the geometric thermal bridging, so making fairly simple shape that can be easily insulated and air sealed. But fantastic double stud approach. This is a case study directly from our blog, so check out the 475 website for more info and our blog. But yeah, thank you everyone for joining. That was today's presentation on double stud wall construction. And I'll be able to stick around and answer any questions that have been coming up in the chat. I know that was a lot fairly quickly, and I'm looking to see that there is a fair amount of questions, which is fantastic. The first question that I'm seeing is, can the double studs be replaced with I-joists? I'm a big fan of the I-joist assembly, also known as a Larson truss. So that approach has an interior structural wall, and then you are hanging an outrigger outboard of that. It does not have its own bottom plate typically. So that might be a TJI, a wooden I-joist, or if it's a retrofit, people make what they call a Larson truss. It's really a 2x4 with a piece of plywood, a little gusset for them to screw into that existing structure. And then we cover that outrigger with the Solitex INTELLO Plus membrane. That's our exterior waterproofing that has netting built in to support that dense pack. And then we dense pack a bunch of cellulose behind there or other types of vapor, open, fluffy, fibrous insulation. So a slightly different approach, but still a great approach. What's lower risk about the I-joist is that the sheathing is inboard of your insulation. With double stud, your sheathing tends to be on the exterior side. So that's where that INTELLO membrane that's vapor variable becomes even more key. So that's what I was highlighting in those WUFI hygrothermal analysis. When you say drywall is airtight, are you assuming drywall installed as airtight system or that drywall as a component is airtight? I was referring to within the modeling program, the material itself is airtight. It is rarely installed in an airtight way. And even if it's initially installed airtight, there's a lot of durability and longevity concerns with relying on drywall as your primary air barrier. It gets very complicated how you transition that air barrier through a floor system or how you sealing around your outlets. What do you do once a homeowner hangs a new picture and compromises that air barrier? So within the modeling, it's considered airtight, or it is airtight. And I think why I was really highlighting that is because I think it's very impressive of how greatly the moisture content is reduced just from the vapor variability of the INTELLO. I tend to see a lot of these comparisons, and I'm oftentimes thinking, well, maybe they just need a interior air barrier regardless of the vapor variability. And for looking at this modeling, we can see that that vapor variability is incredibly important. And that specific vapor curve that INTELLO has is what's really key for reducing the risk, along with it being airtight. Yes, this blue line does not include INTELLO, but I'm not referring to a poly membrane behind the drywall. That was very common in the kind of late 80s, early 90s, and it led us to the sick building syndrome. The concern with poly behind the drywall is that it is vapor closed, and also that we weren't providing balanced ventilation. So the INTELLO is not poly. It is vapor variable. It will never trap moisture because it will respond to that relative humidity and become vapor open. So we are not putting a plastic vapor closed material behind the drywall. That is quite risky. I'm now seeing another question. In the model walls, how is the INTELLO vapor barrier detailed at electrical receptacles? What about can lights? I've had pushback from contractors on penetrations through the INTELLO barrier. Is the performance meaningfully better even if these penetrations are just completed using gasketed faceplates and typical recessed lighting housing? So a lot of projects are including the service cavity, the strapping inboard of the INTELLO that's creating a chase to run those electrical components so they won't penetrate that INTELLO. But you can do without that, but you do want to air seal around all of those outlets or your can lights and things. Devil is in the details. That is where things get nitpicky. So set up your electrician with a bunch of the LESCO boxes that 475 provides. That's a hard plastic box that kind of creates an alcove within the INTELLO that you can place whatever light or outlet within. But an air leak at your outlet or whatever it might be is risky. We don't want that warm interior air to move through that insulation where it would meet that cold sheathing where it would condense. So what we're typically seeing with projects that are doing like the airtight drywall approach is that the air leak is happening at that outlet and it's coming in, excuse me, and then that warm air is moving along that backside of that sheathing and condensing, and then oftentimes exiting at a floor joist system or at the top of the wall. That is very common. Can rock wool or fiberglass be used instead of cellulose? Yes, rock wool or fiberglass can be used instead of cellulose. I really like cellulose or other more like wood fiber and natural fiber materials because they are more hygroscopic. Hygroscopic is meaning that it's picking up the moisture around it and distributing it evenly throughout its material. Hydrophobic would mean that it won't allow that moisture to accumulate within it. So scopic, it acts like a sponge. So cellulose has that really good storage capability. It can really safely hold that moisture, similar to wood fiber and I believe also like sheep's wool. So that hygroscopic insulation is kind of creating this buffer and helps us safely store that moisture so then we can dry through diffusion. It's problematic if you have a bulk water leak to it. It will keep on acting like a sponge and want to soak up that bulk water. But a bulk water leak would make all of this fail. And the problem is the bulk water, not the insulation. So we do want to make sure that we're waterproofing all of this fibrous dense pack insulation very adequately. Cellulose has kind of gotten a bad rep over time, mainly for it being considered too easy to settle. That's where it might not have been installed at the proper density, so it can kind of slough or settle over time, and then we could have these voids. And the way to combat that is install it at the proper density. The insulation should be able to be dense enough to self-support. So a really kind of easy way to play quality control is you can scoop some of that insulation out at the lower portion of the wall within the bay and see if anything moves. You should be able to remove a handful at the base and nothing settles above it. So it should be dense enough to self-support. What is your experience with getting sufficiently good installation from the trades who install the WRB outside and INTELLO inside? I know the lab analysis will show the theory, but what is the reality like out on the job site? Yeah, so in general, contractors are very comfortable installing a membrane. That is not difficult. It really is the transition points that get complicated. And I think the best way to, educate and reduce that risk is to do pre-construction building mock-ups, in particular, a window install mock-up. There is no one right way to do this, but there are wrong ways. So let's do a mock-up before the actual project, get the various trades on site, talk through the transition, the sequencing, have a few different tape options on site during the mock-up, get the actual installers' hands using these materials so they can kind of learn on that mock-up instead of the job site. The most costly thing is having to undo and redo work. So it might seem like it's a burden in terms of cost or scheduling to do a pre-construction mock-up, but it's really the best way to prevent future costs down the line. So big fan of pre-construction mock-ups. But there is really nothing difficult about installing these membranes. They just need to make sure that they're taping the seams and pressure activating the tape. But it will get a little tricky around the transitions. So move much more towards this like integrated design build approach. Bring the builders on earlier on in the project, discuss these transition points with them, highlight any sequencing concerns. And this is a huge way that 475 can support. The sales team is oftentimes bouncing these drawings back and forth with the designer, talking through different options, and then oftentimes working with the builder, one, to provide takeoffs and estimates, but two, to discuss sequencing and different options for these transition points. So please reach out to your local 475 rep and include them in this conversation. They can be helping highlight these sequencing transitions and these little details. Both assemblies, INTELLO and no drywall, do dry seasonally per the graphs. What is the time frame which 20% moisture content becomes an issue? Thanks. Yeah, so it's kind of different for each material, i.e. the substrate. When I ran these WUFI hygrothermal analysis, I also ran a mold growth analysis on the backside of the sheathing. That's a mold growth analysis based on ASHRAE 160P standards. And so there's a materiality class within that analysis where it's saying how susceptible to mold growth it is, or how much it would kind of fail once it started to get a little wet. And all of these assemblies went from a yellow light, i.e. you might have some mold growth, but maybe not enough to cause any true wood rot concerns, to a green light, i.e. no mold growth concerns, by utilizing INTELLO. So when you were relying just on the airtight drywall for these climate zones with this specific assembly, the ASHRAE 160P mold growth analysis was showing a yellow right, meaning needs further review, might be a little bit risky. But what's the time frame for when the above 20% moisture content becomes an issue? It's really different depending on the substrate. But we want to keep that for as short as possible, and kind of ideally when it's cold out, i.e. when there's not warmer temperatures that can more readily propagate mold growth. So yeah, it will be a little bit different depending on what that substrate is. With level 3 double stud wall, the intelligence is on the outside of the interior wall, and you end up with a surface cavity with little to no penetrations. Yes, that is a really great approach. By utilizing that interior wall as structural, we can then place the INTELLO outboard of it, and now that interior wall is doubling as our surface cavities where we can be running our utilities. Does WUFI have the ability to change the perm rating of the INTELLO layer throughout the months of the year when it runs its analysis, or is this a static perm number? The WUFI hygrothermal analysis is reading from product data to show and read that the INTELLO is vapor variable. It is responding to that relative humidity within the model. So it is not a stagnant vapor permeability. The plywood is also, the plywood is also a little bit vapor variable, but all the other materials within this assembly were a static permeability. The Solatex Mento 1000, I believe, is US perm of 38, so quite high permeability. But yes, the WUFI hygrothermal analysis, we are able to model vapor variable materials. If the interior drywall is not detailed to be airtight with the non-INTELLO scenario, how does that impact? Say 15% more air leakage, assuming exterior Mento is primary, INTELLO is just icing on the cake. All of these models would look a lot riskier if it did not include an interior air barrier. Then you're having your warm air move through that insulation where it would condense on the backside of that cold sheathing. So if you don't have exterior insulation, you really should have an interior air barrier. And then we further reduce that risk by making it vapor variable. I did not run these assemblies without drywall or working in like an air leak or anything like that. But I would say they would be significantly riskier. Again, it's all about avoiding that cold soda can out in the summer day. We want to prevent our warm air from meeting that cold surface. So we really need that interior air barrier. I'm building now with exterior wall structural on a slab. Does the slab vapor barrier seal to the exterior wall or to the interior wall to the INTELLO? That project case study that I showed, the subslab polymembrane came up and was taping to the mento on the exterior. I'm typically seeing that poly taped to the exterior waterproofing. I'm oftentimes taping that to the plywood sheathing and then having my house wrap overlap it. So I'm still shiplapping that seam. And then we're typically taping the INTELLO to the poured concrete slab. Poured concrete is airtight. So oftentimes our foundations have multiple air barriers. But it does get very project specific. If you have a stem wall or something like that, so reach out to your local 475 sales rep for discussing a specific project. Double stud in climate zone 7 or 8 can be done. You'll really want to prioritize that interior air barrier with the vapor variable membrane, with the INTELLO Plus membrane. So then that sheathing is getting quite cold. I am seeing some of those projects switch to diagonal strapping instead of a plywood sheathing or OSB sheathing because they're really only ever drying outwards and they don't want the permeability of that structural sheathing. They want it even more vapor open. So a lot of those assemblies are, adjusting their assembly to be climate zone specific by eliminating any level of vapor retarding on the exterior that could occur from the plywood or OSB. On balance, do we like double stud versus exterior insulation due to costs, difficulties installing the exterior insulation? What I really love about double stud is we can use a lot of low cost fibrous insulation. And that low cost fibrous insulation is a craft, is a skill to install. So we're shifting the budget from an exterior rigid board that costs a fair amount but is very easy to install to a lower cost material that is a craft that we can then pay a trade, a craftsman to install that and be supporting that worker directly. We really want to be creating good jobs. And so if we can be, designing our assemblies to be prioritizing that craftsmanship and be using low cost natural types of materials and insulation, then we can be creating really great, healthy, well-paying jobs for those workers. A lot of the US, in particular, construction industry has really been focused on how can we do this as cheaply and quickly as possible. And a lot of that emphasis tends to be, let's buy a high cost material that any dum-dum can install. So we tend to be losing a lot of the craft within the building industry. So I'm a big fan of using fibrous insulation and getting someone that, has a cellulose blower system and setting them up with some good work and creating great new jobs. Happy to be in touch with a copy of the slide deck. Feel free to reach out directly. And I believe a recorded version of this will be available afterwards. Especially in assemblies where the membrane is deep in the center, we're relying on the lifespan of the membrane for long-term durability. Do we believe that these membranes have equivalent lifespans as structure? So the INTELLO membrane has actually gone through some simulated age testing. And there will be a new blog post coming out shortly on the 475 website with more of the actual data on that. But at 50 plus years, it is still incredibly airtight, and actually the slight change in the vapor permeability based on low relative humidity or high relative humidity actually becomes better. It becomes a slightly more vapor retardant and slightly higher vapor open in its permeability. I would think that the adhesive and the tape is probably the quickest thing to fail within this like membrane air sealing vapor control layers. And we've also done simulated age testing on those adhesives to show that they should be lasting at least 100 years. So the tapes, the adhesives have a 100-year timeline. And I believe the Living Building Challenge, that certification, that declare label type of system, is claiming that the membranes have a 50-year timeline. So we are looking at a nice long lifespan for these components. What is the downside of wrapping the rim with Minto or INTELLO where the exterior wall is the structural wall, besides being out of sequence? Or how much impact does moving the vapor barrier to the outside of the installation at these locations impact the overall envelope performance? Tape around each floor joist seems to open up a lot of potential for install area error. Yeah, so I'm moving through to this assembly. Just having a continuous and complete air barrier is what's really key. I do get worried about taping around all of these floor joists. But if there's any high risk point, it really is our floor joist system. Energy moves much more freely with the grain of wood opposed to across the grain. So we do want to, super insulate our rim joist and floor joist system. And I do prefer to keep that interior air barrier at that floor system. I still do wrap that rim joist with either a membrane or tape. I prefer a tape mainly because of the building corners. The membrane gets more complicated to tape at the corners. But then I'm oftentimes coming back and I tend to use blocking that I then spray the joints with Viscon. That seems to be a nice balance of we're working with trades that might not be as familiar with these air sealing approaches, but they're used to installing blocking. The hard thing is getting that tape or membrane down during the framing stage before they set down that floor system. So there's nothing difficult about that. It is really just a timing thing. So again, pre-construction mock-ups, meetings, educate these builders, talk through these things with your framers. We're moving much more towards that integrated design build approach. Why not using the sheathing layer, OSB or plywood sealed for vapor barrier on the interior and use a highly permeable layer like a wood fiber panel on the outside and acting as an air barrier? I'm not sure I'm fully following that. Wood fiber board is not airtight. We do want a dedicated air barrier, but it sounds like you're kind of moving maybe towards an I-joist assembly where that interior wall, that sheathing can be your air barrier, and then we have an I-joist outrigger or some type of thick layer of vapor permeable insulation. So the INTELLO becomes really key because we're not having exterior insulation. And what we were showing in that WUFI hygrothermal analysis is that that vapor variability is very key for reducing risk. It is not just the air sealing. Have you ever run into pushback from building inspectors about double studs and requirements for fire blocking every 10 feet inside the wall cavity? I ran into issues in terms of them signing off on framing and then there's new framing later on. So just scheduling your inspections can get a little tricky for these high performance approaches, especially if you're doing the interior wall as your structure. Because your electrical needs to be roughed in for them to sign off on the framing, from my experience. So we tend to be needing them to sign off on the framing so then we could be working in our service cavity or other types of electrical components. So again, it's just communicating things with your inspectors. Do you recommend using 1/2 inch or 3/4 inch plywood top and bottom plates to prefabricate double stud walls? I guess I'm not fully following that. If you want to change the thickness of the exterior sheathing, that's totally fine. I find half-inch CDX plywood is low cost, readily available, and nice permeability. I could see, a lot of these double stud walls don't have quite as thick of a gap in between, and they oftentimes have a single bottom plate. So they might just be using like a 2x10 as their bottom and top plates, and then they're just staggering the wall framing in between. My concern with that is that we're having thermal bridging at the top and bottom plates. But feel free to follow up with me directly. I don't believe I'm answering your question adequately. I'm not quite following it. Yeah, for those sticking around, thanks for sticking around. And next question's from Dan Fortin. I built a double wall home in 1982, used a poly at 75% inside, used fiberglass insulation, 2x4 studs, 6 inches between studs. We are in heating zone 7, wall R40 and ceiling R90. Nice robust thickness on that roof in particular. No issue with vapor condensation as yet. Yeah, so hearing that you're in climate zone 7, that's where you're really always drying outwards. You're probably never really drying through diffusion inwards. So it makes sense that you're able to get away with a truly vapor closed interior air barrier. Most other climate zones were drying in both direction based on the season. So then we want that vapor variability of the INTELLO. But if you're only ever drying outwards, the poly could be appropriate, but I would still, rather reduce the risk, or as climate change is happening, maybe your summers are getting more extreme and you might need to be drying inwards for a few months of the year. Double stud walls in the 1980s with fiberglass insulation were a mouse favorite. When opened up, now the insulation is a mess. I would avoid fiberglass. Yeah, when fiberglass gets wet, it tends to bunch and kind of slough. It won't like hold its shape as well. And a lot of these older projects probably weren't having proper air sealing, or there might have just been a bulk water leak. So I do think of, cellulose or wood fiber or even chopped straw can be lower risk than fiberglass. I think we like to highlight that fiberglass is possible because it is a much lower cost than a lot of these other options. In terms of renovation and ceilings, attics, would it be possible to put INTELLO on top of the ceiling joist and then layer insulation, example, unfaced rock wool over it? Yes, we are doing a lot of unconditioned attic retrofits where people are removing whatever is on that floor of the attic, and then that INTELLO membrane can pinch around the ceiling joists, and then they just dump loose fill insulation on top, cellulose or fiberglass or similar, and that's a great approach. It's keeping the INTELLO on the interior side. We can pile a bunch of loose fill insulation that's very easy to install, and then that cavity above is vented oftentimes at the gables and the eave and ridge vents. So that's a really great approach for a retrofit for an unconditioned attic. What are your thoughts on 3D vent mat versus vertical wood strapping for double stud assembly? This is, I believe, referring to the rain screen that is outboard of that house wrap, whether it's the Solitex Mentum membrane or the Adhero membrane. I like vertical wood strapping again because it's a low cost material, and then I'm putting the money to the laborers instead of the material. But there's a lot of these 3D mesh options now available that are quite easy to install, in particular if you have vertical siding. Because if you have vertical siding, then if you're using a wood strap, you need 2 layers of straps. One against the house wrap that's running vertically, and then a counter batten system, a batten outboard of that runs horizontal to hold that vertical siding. So I'm seeing a lot of projects that have vertical siding or cedar shingles or things like that, where then they're then switching to the 3D mesh product, whether that's the mortar vent for the walls from 475 or the R vent product from 475 for pitched roofs assemblies. But either approach works well, and I'm seeing the 3D mesh much more for vertical siding. Horizontal, I'd say might as well keep on using vertical wood. Nothing can beat that. It's nice and simple. I don't see a lot of details showing balloon framing and hanging the floor assembly onto the interior of the interior 2x4 wall, and then having the INTELLO one straight up the flat wall and then install the floors. So maybe this is that the exterior wall is balloon framed and the interior wall is structural and not balloon framed, so that's holding that floor system. Yeah, in general, I find balloon framing a little worse. I know it can be done and makes sense, but I'm too concerned about wildfire approaching and things like that, and just kind of get skittish around balloon framing. But I would say if it's a non-structural wall on the exterior, it could make sense. I'm not sure if I fully followed that question. Thanks everyone for sticking around. Please check out our website and follow up with us and let us know how we can be supporting your specific projects.